So today we are discussing chapter 4, forces in one dimension. Okay, forces in one dimension, and lesson 1, force and motion. What is the meaning of forces in one dimension? Force acting in one dimension. What is the meaning of that? Can you give an example for a force that is acting in one dimension? Okay, for example, like you said like this. For example, this is the floor. Okay, this we can say this is the floor. First I was about to draw the table. Okay, this is a floor, and here there is a box here, and you are pushing the box. Okay, you are pushing this box, means you are applying a force F, and you are moving, you are like this pushing the box, and you are moving the box up to here. Now the box reached here. So here you can see, in this case, force is acting only along this direction, right? You are applying force only along this direction, means you are applying force only to the right side, correct? You are applying force in one direction, to the right side. Or we can say you are applying the force in a horizontal direction. You are not applying any force in vertical direction. Or we can say you are applying a force only along the x direction. You are not applying the force in the y direction. So here force is only in x direction. So only in one direction, right? X direction. Force is along the x component. So that is called one dimensional force. So here you can see there will be one more force acting on this box. Can you tell what will be the other force acting on that box? That force will be frictional force, right? Frictional force will be acting in the opposite direction. The ground will be pushing the box in the opposite direction. That is called the frictional force. You can see this also acting along the x direction, right? This, in this case, it is in the negative x direction, but it is in the x direction, right? Not in y direction. We can say like here there are two forces acting. One is in the horizontal direction, other also in the horizontal direction. One is in the positive x direction, other in the negative x direction. There is no force along the y component. There is no force along the z component or z direction. So force acting only along the x direction, or only along the y direction, or only along the z direction, means force acting only in one direction, is called one dimensional force. So in this chapter we will be discussing about the forces that is acting only along one direction. Is it clear? Contact forces and non-contact forces. Contact forces and non-contact forces. So here I will write contact forces. Here I will write non-contact forces. Okay. Can you tell what is the meaning of contact force? What is a contact force? Yes, correct, very good. So contact force means to apply a force. To apply that force, you have to touch that object, right? To apply the force, you have to touch it. Means there should be a contact between the agent and the system. We will study what is agent and the system, okay, later. So what is contact force? to apply that force there should be a contact, right? For example, I am taking this mouse, so I have to touch the mouse, right? I cannot move the mouse like this without touching. We cannot move the mouse, right? So here I am using the mouse, so I need to touch it. If I want to take this water bottle, I have to touch the water bottle. There should be a contact between my hand and the bottle, right? So that type of force is called contact force. So to apply a contact force, there should be means a touching, or we can say there should be a contact between the agent and the system. So contact force is applied by contact. So by contact I will write the force applied by contact. Can you give some examples for contact force? Yes, push is a contact force, right? Push or pull, but that can be non-contact force also. Okay, push or pull is the general definition for forces. In general, what is a force? A force is a push or a pull acting on an object. Every force will be either a push or it will be a pull in all the situation. So that is the general definition for force. A force in general is it is a push or a pull acting on an object. Examples for contact force, for example, here you can see there is a laptop here on this table. So the table will push the laptop upward, right? That is called normal contact force or normal reaction. So normal force is a contact force. Normal force, example is normal force. For example, I will tell here, like this is your table, and on your table there is a book. This is your book on the table. So what will happen? The table will push the book upward. This force is called normal force or normal contact force. So this is normal force is an example for a contact force. Do you understand? Okay. Then next example for a contact force is, can you tell any other example for a contact force? Yeah, book on table. So table will be applying an upward force on the book that we have discussed, right? Then second type of contact force we can say, like for example, now I am moving this mouse on this table. So there will be a frictional force acting, right? The table will oppose the motion of that object on the table. Okay, like for example, if a ball is rolling on the ground, the speed of the ball will gradually decrease, right? And eventually the ball will come to rest. Why the ball come to rest? Because speed decrease. Why speed decrease? The speed is decreasing because of the frictional force acting on the object. Okay, the speed of the ball is decreasing because of the frictional force acting on the ball. Do you ride a bicycle? Okay, so for example, you are pedaling the bicycle. Okay, so when you pedal, it will go faster, right? Can you tell what happens when you stop pedaling? What will happen when you stop pedaling the bicycle? If you stop pedaling, first you were pedaling, so it was going faster, then you stopped it. So what will happen? Its speed will be gradually decreasing, right? Can you tell why the speed is decreasing? Okay, because you are not applying a force and there is a frictional force acting. Frictional force means the first one, the ground the ground will be, or that road will be opposing, or will be applying an opposite force on the tire of the bicycle. Because of that frictional force, the speed will be decreasing. So for a frictional force to act, there should be contact between two objects. The tire should be in contact with the road. Okay. Third type of force, third force as example for a contact force. Can you tell any other force? So this is frictional force, right? Second one, friction. Third is air resistance. Air resistance. Air resistance is a contact force. Do you know what is air resistance? For example, we will say like for example, if you are riding the bicycle, then air will be also pushing you backward, right? Air will be pushing you backward. Did you feel that when you ride the bicycle? Okay, that is air resistance. That is acting when air is in contact with you or in contact with the bicycle. Okay. Then another force, another example for a contact force is tension. Tension force. Tension force is also an example for contact force. Tension force means, for example, if there is a rubber band, if I stretch the rubber band, if I stretch it, so there will be tension, right? Tension will be acting. Okay. The stretched rubber band will be applying a force on my hand. That force is called tension force. For example, if you take a rubber band and like this, take a piece of paper or anything, then make it like this, and if you release, the stretched rubber band will apply a force on that paper. So the paper will move, right? The object will move. So that is a contact force. Okay, tension force is an example for contact force. Tension force is the force applied by stretched materials. Example is rubber band. When rubber band is stretched, it will apply a force on the object. If you release it, that force is called contact force. That force is called tension force, and tension is example for contact force. Do you understand these things? Okay. Can you tell what is the meaning of a non-contact force? Yes, non-contact force, for the force to act, no need of contact between the object, right? You said example magnetic force, right? Yes, here we have a magnet here, a bar magnet. It is north pole and south pole, okay, and here there is a nail here, a nail. So this magnet can attract the nail, right? Or a piece of iron, So magnet can attract it, right? Can the magnet attract that nail, that iron nail, without touching the nail? Yeah, without touching, right? So non-contact force means the force which can act without contact, with contact or without contact. And you gave a very good example, that is magnetic force, right? So magnetic force is a non-contact force, because for the magnetic force to act, there no need to be contact between magnet and the other object. Can you give one more example for a non-contact force? One more example can you give for non-contact force? No, air resistance is contact force. For air resistance to act, air should be in touch with the object. Without touching with the air resistance will not act. Another force is electric force or electrostatic force. Electrostatic force. So what is electrostatic force? Force between electric charges force between electric charges. Like, did you ever see, if you take a balloon, okay, if you take a balloon and if you rub the balloon with your t-shirt, then if you like means bring it near to pieces of paper, so that paper will be attracted. Did you ever see that? Okay, so that is electrostatic force. Okay, that is electrostatic force, or we can say electrostatic force is the force between electric charges. In an atom, there will be attractive force between electrons and nucleus without touching. Electron and nucleus is not touching. Still there will be force between electrons and nucleus. That is electrostatic force. That is an example for non-contact force. Third one, can you give one more example? Another example is nuclear force. Nuclear force. Nuclear force means force between the nucleons. For example, in a nucleus there will be neutrons and protons. So there will be a force acting. That force is called nuclear force. Force between the nucleons. Okay. Next, we will discuss system and agent. Have you studied this system and agent? Okay, yes. Okay, so can you tell what do you know about the system and agent? Okay, so can you tell what is there on your table? Can you tell any object that is on the table? There is a notebook, right? Okay, can you take that notebook? Just can you lift it? Okay, so you are applying a force on that notebook, right? You are applying a force on the notebook and the notebook is experiencing the force, correct? Notebook is experiencing the force. So what is system? System means object experiencing the force. Experiencing the force. That is called a system. Okay, so you are taking a notebook, for example, this is not notebook. So you are taking, this is a textbook. Okay, you are taking this textbook like this. So which object is experiencing the force? When I am taking this textbook, the book is experiencing the force. So here the book is the system. The object which is experiencing the force is the system. And what is agent? Agent is the object that is applying the force. So here what is applying the force? My hand is applying the force, correct? Okay, so hand is the agent. Do you understand? Hand is the agent. So agent, what is agent? Agent is object. Agent is object which is applying the force. Object which is applying the force. That is called agent. Is it clear? Okay, for example, here there is a table. On this table there is a bowl, or in this bowl there are some fruits, for example apple, orange, like that fruits. So here this table will push, the table will push this bowl upward, right? Correct? Okay, so every force that we will represent by the letter F. Do you understand? Force we represent by letter F. Then with F we will write subscript. With F we will write a subscript. So what does the subscript represent? Subscript represent like this: agent on system. Okay, agent on system. This is the subscript. So here on this bowl, what is applying the force on the bowl? Yeah, which table? Table is applying the force, right? So we will write like this: F table. First we will write agent. Okay, first we will write agent. Okay, first we will write agent, F table, then write on system. Here what is system? System is the bowl, right? Very good. System is the bowl. So always agent on system. If you confuse which one to write, system on agent, like system first or agent first. So you can remember like this: subscript is in alphabetic order. Subscript is in alphabetic order. Agent first, system second. So F table on bowl. Then one more force will be acting on this bowl, that is weight of the bowl. Means earth will be attracting the bowl downward, correct? Earth will be attracting this bowl downward. So this is a gravitational force, right? This is a gravitational force. And there is one thing: gravitational force is a non-contact force that we forgot to write in the examples. Okay, examples of non-contact force. So that also you remember. So we represent this force by the letter F. What is the agent? Means which object is applying that downward force on this bowl? Which object is applying that down? Gravity means earth, right? Or we can say mass of earth. Mass of earth. I am writing mass of earth completely because it is how it is given in the book. Mass of earth on what? On system. What is system here? System, bowl, on bowl. Very good. Then I will ask you a very simple question to check, are you thinking in this way? So can you tell what are the differences between these two forces, F table on bowl and the F mass of earth on the bowl? Can you tell what are the differences between this force and this force? They are both okay, very good. Both the forces are acting on bowl. Very good. Both the forces are acting on same object. Very good. That is number one. Okay, can you tell another one? They are both forces. Okay, and I asked the differences, right? You said the similarity. Both forces are acting on bowl. That is the similarity, right? I am asking what are the differences between this upward force and downward force? Very good, excellent. I was waiting for that answer. Which one is contact force? Yes, this is a contact force. So you understand, right, what is contact force? And this one is example for non-contact force. Gravitational force is a non-contact force. Very good. Okay, so do you understand what is system and agent? Okay, perfect. Next we will talk about free body diagram. Okay, we will talk about what? Free body diagram. free body diagram. Are you writing notes? Okay. Can you tell any one object that is on your table now? A water bottle. Okay, how will I draw if it is a book? Water bottle, okay, like this. Not good. No, okay. So there is a water bottle on your table. Okay. So this water bottle, what are the forces acting on the water bottle? How many forces will be acting on this water bottle? Can you tell? How many forces? 2 forces. Very good. I was expecting that answer. 2 forces will be acting. 2 forces will be acting on the water bottle. Can you tell what are those 2 forces? Yeah, okay. First one is the upward force, correct? Okay. So we will draw this. We will represent F. Okay. What is the agent? Which object apply this force on the bottle? Which object is applying this force on the bottle? The table, right? So we will write F table on bottle, correct? F table on bottle. Then what is the second force acting on the bottle? The second force is weight. Very good. Weight, right? Weight of the bottle. So F mass of earth on bottle. Okay. So this is the this is a diagram. This is not a free body diagram. So this is a diagram or a sketch of forces acting on this water bottle that is on your table. Now we will draw free body diagram for this. Okay, free body diagram. So what is free body diagram? Free body diagram is a simple way to represent all the forces acting on an object. What is free body diagram? Free body diagram is a simple way to represent all the forces acting on an object. Is it clear? Okay. So in free body diagram, here what is our system? What is the system in this example? System is the object experiencing the force, right? Which object is experiencing the force? The bottle is the system. Okay. So in free body diagram, we represent the system by a dot. So we will not draw the bottle. Okay. We will draw a dot. This dot represent the system. Now this dot represent this bottle. That is the first step. After that, we have to identify what are the forces acting, in which direction the forces are acting. So here there is one upward force acting. This upward force is F table on bottle, and there is a downward force acting. So when we draw free body, that means in a free body diagram, we represent the forces by drawing arrow. That is the second point. Okay, first point, represent the system by a dot, represent the object by a dot. Second point, the forces are represented by drawing arrow, and arrows are always drawn away from the system. Okay, you can see arrows are drawn away from the system. We will not draw the force, for example, the downward force we will not draw like this. Okay, we will not draw towards the dot. We will always draw the forces away from the dot. This force is also away from the dot. So here we will write F mass of earth on bottle. So this is the free body diagram for this example. Okay, this is the free body diagram for this example. So if there are, for example, if there are three forces acting, then we have to draw three arrows to represent all the forces acting on the object. Is it clear? Okay. Then yeah, I will give you one more example. Okay, one more example to draw free body diagram. And after this we will discuss net force. What is the meaning of net force? Have you studied net force? Not studied? Studied. So you know, right, what is net force? Okay, no problem. So here this is like a inclined surface. Do you know what is inclined surface? Okay, so this is inclined surface. Inclined surface, you don't know what is inclined surface, right? No problem. So this is a slide in a children's park. Do you know that? In a park there will be slide, right, for the children to slide down in children's park. So for example, you went to a park here, in a children's park, and there is a slide and you are sliding. For example, you are here. So there will be three forces acting on you. Can you identify what are the three forces? What will be the three forces acting on you when you are sliding down on a slide? Okay, so one will be your weight, right? So weight will be always acting vertically downwards to the center of the earth, because earth will be pulling you downward. Earth will be pulling you to its center. So weight will be always acting vertically downward. Okay, that is one of the force. So this we will write weight, right? Or I will write force of gravity. Okay, Fg I will write force of gravity. Yeah, what is the second force? Like normal force, right? Normal force will be always normal to the surface, means perpendicular to the surface. Is it perpendicular? Perpendicular means this angle should be 90 degree. Okay, this must be 90 degree. So that is why it is called a normal force. Okay, normal means perpendicular, angle is 90 degree. So this is normal force. We will write Fn. Do you understand? Like this is inclined surface, right? If it is a horizontal surface, like this, then normal force will be acting upward direction, as you said. Okay, now this is not an horizontal surface, right? This is inclined surface. See, when the surface is inclined, normal force will become like this. It will be always perpendicular to the surface. Normal force will always make angle 90 degree with the surface. Is it clear? Okay, very good. Then what will be the third force? You are sliding down, right? So what will be the third force acting? Third force will be frictional force. Frictional force, because if any object is moving over another object, now you are sliding or moving on the slide, right? So if any object is moving on another object or another surface, the surface will be applying a backward force. Now you are sliding down, so the slide will be applying a backward force on you. What is the name of this force? What is the name of that opposing force which opposes every motion? Friction. Very good. Friction. So friction, we will write friction. So these are the three forces acting, but this is not a free body diagram. So how to draw free body diagram? In a free body diagram, we represent the object by a dot. That means we represent the system by a dot, and this is one of the force acting, force of gravity. This is the second force acting, normal force, and this is the slide is like this, right? So this is the third force acting, that is the force of friction. So this is how we draw free body diagram in different situations. I hope you understand this. Is it clear? Okay. Then next we will discuss about the net force. What is net force? Okay. So here there is a table. For example, this table is a dining table in your house. What you are doing, you are pushing the table, you are pushing this table to this side. Oh, okay. Anyway, you are pulling the table to this side. Okay, you are here, and you are pulling this table to the left side, right? To the left side with a force of 100 Newton. Your sister is pulling this table. Your sister is this side. Okay, she is pulling the table with a force of 100 Newton. In which direction the table will move? Stationary, it will not move, right? Why? Because you are applying the force. Why it is not moving? Why is it not moving? Very good, because equal forces are applied in the opposite direction, right? So both the forces will be cancelled, right? This 100 Newton and this 100 Newton will be cancelled. So net force become equal to 0. That is why the table is not moving. The table will move if there is a net force acting. Every object will move. Every object, if it is at rest, it will start moving if there is a net force acting. Here there is no net force acting. Okay. Then second, you are here. You are pushing this table with a force of 100 Newton, and your sister is also this side. Your sister is also pushing the table with a force of 100 Newton. Now will the table move? Yeah, if it is not very heavy, it will move, right? It will move. So what is the net force acting on the table? How much is the net force acting on the table? 200 Newton, right? Can you tell why? Like you are applying 100 Newton force, your sister also applying 100 Newton force in the previous situation also. So here the net force is 0. Here net force is 200. Why? Same direction. Very good. This is in the same direction. The first one is in the opposite direction, right? So we will discuss what is net force. Okay, what is net force? Net force is vector sum of all forces acting on an object. Net force is vector sum of all the forces acting on an object. Okay, so what is net force? Net force, what is the definition of net force? Net force is vector sum of all the forces acting on an object. Is it clear? Everything clear? All clear, right? Okay, so I will give you some questions. Okay, I will give you like 3 questions. I have all the 3 questions from your textbook. So first 2 horizontal forces, I will write here the question. Two horizontal forces, question number 1, two horizontal forces 225 Newton and 165 Newton are exerted. 225 Newton and 165 Newton are exerted on an object. If these forces are applied in the same direction, if these forces are applied in the same direction, find the net force acting on the object. Find net force acting on an object. Very easy question. There is an object here and 2 forces are acting, right? What are the 2 forces? 225 Newton and 165 Newton. Here you can see, when I was drawing 225, I drew a longer line. So when I was drawing 165 Newton, like shorter line, it is because the length of the line must be proportional to the force. Okay, if the force is greater, you need to draw greater line, means a longer line. Are you here? Okay, so what is the net force? Can you tell what is the net force? How much? Yes, it is the vector sum of all forces, but calculate and tell what is the answer here for this question. What's the answer? You said like this, right? 225 plus 165, that is equal to how much? 390 Newton, right? So here you can see forces are in the same direction, right? Same direction. So if forces are in the same direction, how to find the resultant? By adding, right? Then resultant is by adding. If forces are acting in the same direction, you can calculate the net force. Net force is also called resultant force by adding the forces. Then in that next question, okay, second question is, if these 2 forces are acting in the opposite direction, if the same 2 forces, this is 165 Newton, if this same 2 forces are acting in the opposite direction, what will be the net force? F net. Net force we will represent by writing F subscript net. How much? Subtract, right? So 225 means larger force minus the smaller force, right? Larger force minus smaller force. 225 minus 165. So what's the answer? 225 minus 165, tell. I hope you got 60. 60 Newton is the net force, right? In which direction? In which direction? To the left side or to the right side? To the side of 165 Newton? Yeah, right, because direction of net force will be always along the direction of the greater force, along the direction of the larger force. So net force will be to the right side because 225 Newton is larger than 165 Newton. Okay. Last one more question we will discuss, and we will finish today's class, and in the next class we will discuss Newton's second law. Have you studied Newton's second law also? So you reached up to here in school? Up to net force, very good. So 3 confused dogs are trying to pull a sled across a snow, means on the snow. So one dog is pulling pulling towards east with a force of 35 Newton. Another dog pulling with a force of, that also pulls to east direction with a force of 42 Newton, and a big dog that is pulling with a force of 53 Newton in the west direction. So what is east, what is west? Do you know which one is north? This is north, right? South, west, east, right? Okay, so there are 3 dogs pulling a sled across a snow, and one dog is applying, that is east direction, and this also east, applying a force of 35 Newton, and the second dog applying a force of 42 Newton, and the third one applying a force of 55 Newton in the towards west. So question is calculate net force. Can you calculate this? How will you calculate? So here there are 2 forces in this direction, right? Very good. So you said like this, you will add the forces in the same direction, right? And you will subtract the forces acting along the opposite direction. Very good. So you will be doing like this, right? 35, can you tell? 35 plus 42, right? Minus 55. Add all the forces acting in the same direction and subtract the forces acting in the opposite direction. So what will be our answer? 35 plus 42 will be okay, so 22 Newton in which direction? To east or west? East. Very good. East. Okay, I hope you enjoyed the lesson.